All right, happy Tuesday, everyone. Welcome to our first and hopefully only e-learning day of the year. We need to keep going. We're already behind a little bit, so we're going to go ahead and get through 8.2. I know it sucks, but make sure you take the notes today. The homework's on Schoology under the homework section, and so make sure you check that. You can print it if you have access to it. You can do it on paper, whatever you got to do. If you need a paper copy, stop by tomorrow, Wednesday, and grab a paper copy from me. But this is something that you should try to work on. Okay, so we'll get through the notes. The notes are pretty short. We only have a couple of pages, and this is going to feel pretty familiar, and that's pretty good. So what we're working with here is we know what similar triangles are, right? From the first section here, we know that similar triangles are just resizes of each other, right? If you look at this one, here's a small one, and then there's a bigger one, right? And we know that there's some scale factor that gets us from the blue into the red here. And in addition, all the angles, for example, B and E, all those angles have to match, right? That was the definition of it. And then we learned in 8.1 part B that perimeter holds the same property of scale factor. So you can use the ratio of the perimeters equal to the scale factor in order to set up a proportion. And then for area, you can do the ratio of the areas equal to the scale factor squared to set up proportions. And that was very useful. But now it's more like theoretical geometry, where I have two triangles, and how can I possibly prove that these two things are the same? And by the same, I mean similar. And so if you look back to a few chapters ago, before we moved to the new school, we actually had a whole chapter on congruence. And that was when we learned about, side, angle, side, 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 angle, side, angle, 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 side, and HL. This was all triangle congruence. Triangle congruence from way back in the old school, right? We came back and then we did the stuff on the board in the new one. This was to show that two triangles are exactly the same. The rest of our chapter here is dedicated to showing that two triangles are similar to each other. Not the same, but similar. So let's go ahead and keep going with this. I'm just going to trash that page. Usually you can't see this stuff in class. So the first one that we'll learn is called angle, angle. And if you look at the pages here, you'll see that we get two more next time, side, 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 and side, angle, side. But our first one is called angle, angle. And angle, angle was my example for why two triangles can't be congruent that are just angles. But as far as similarity goes, it's good enough. And so it's a pretty simple theorem. If we have two angles of one triangle that are congruent to two angles of another triangle, so if we can show that two sets of angles match, so there's one set, and here's our other set, so now we have two sets of angles matching, that's enough to conclude that the triangles are similar. Again, we're looking at the different options that we have. Before we had 5, and here's the first one of this type, right? So we look, do we have the same information? Do we have two pairs of angles that are congruent? If so, boom, triangles are similar. It's pretty simple because all you have to do, if you have two of them, then of course you have the third one, right? Because whatever this angle is right here, say this is 40 and this is 30, well, this is going to be 180 minus 40 minus 30. And so of course, these two are going to match. Okay, I'm erasing that, so that's what's so messy. Okay, so it's a pretty simple proof. Nothing too serious here. This is called angle-angle similarity. AA is the symbol we will use. So that's the only one we know right now. Okay? So the first example is determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So here we have triangle CDE and triangle HGK. We have 64, 90, 90, and 26. Now, of course, we need to do the normal thing that we would do, and we can do 180 minus 90 minus 26. And I'm looking at this triangle right here, right? I'm trying to find angle E. So this is going to be equal to the measure of angle E. And so if you actually subtract those, you get 90 minus 26, and what is that? 64? Measure of angle E is equal to 64. So we can take that and place this right here. So 64 degrees. All right, so now we know that we have two sets of angles that match. So we're going to go ahead and show that. So we have measure of angle E is equal to measure of angle H, and we have measure of angle D is equal to measure of angle G. That one's given. Those are both 90, right? So these two things together imply, again, that's what that double arrow means, right? This is imply that triangle, let's go CDE. Now do keep in mind that this order does matter, right? So C's first, then we need to make sure that the one that matches C, so K is first, D is second, so we need to go to G, and E is third, so we need to go to H. So CDE matches KJH. Those are similar triangles by angle similarity. So this right here is our conclusion. We have shown our steps, and we have developed a conclusion. Now, this should remind you of the proofs from before we move schools, and we'll get there eventually. We'll be doing proofs eventually. Okay? So there's number one. Not too bad. Number two, show that the two triangles are similar, right? So we're trying to show that triangle ABE. So ABE is this little guy right here. We're trying to show that that's the same as the whole thing, ACD. So one thing to keep in mind here is we actually have this angle right here is already matching. And so you need to look for a second angle that matches, but this is tough because we don't know for sure that EB and DC are parallel, right? If they were, we could say that these are the same, right? But we don't know that, so we can't do that. And hopefully you see what the matching angle was, but if you were to take this and draw them separately, you'd have your little triangle and you'd have your big triangle. I'm going to erase this just so you know. And both times you draw this, you'd have angle A on top. And what that means is that angle A is actually congruent to itself. So we have two angles that match here. We have angle A is congruent to angle A. I dropped the measure this time. And that's that reflexive property where everything is congruent to itself. So that's one pair of angles that matches. Then we have angle ABE. That's our 52 in the small triangle. That thing is congruent to angle ACD. That's the 52 in the big triangle. So here we have two different pairs of angles that match. So this implies for us that triangle ABE is congruent to triangle ACD by angle similarity. Boom. So two matching pairs of angles, good enough for us. Okay. All right, number three. Show that those two are similar. So SVR is the left one and UVT is the right one. So we're saying S and U are the matching angles if this works, right? So go ahead and take just a second. Pause me right after I finish this sentence and see if you can figure out what three angles or what two angles might match. All right, hope you're successful. So the biggest thing here is that we have to look back a little bit in time and think about those things that we know we could mark. And we did really well with that. You all did very great. And so the biggest thing is right off the bat, we know that this angle right here, SVR, matches this angle right here. Do you remember why? Hopefully you're thinking vertical angles. And right now we're not giving any proof, but keep that in mind, right? It's important to remember that these are vertical angles. And so we can write for our first pair, because we need two, angle SVR is similar to angle, not triangle, excuse me, angle, and it doesn't matter which order we go in as long as V is in the middle, so I'm going to go UVT. So angle SVR is congruent to, what's wrong with me? I'm so sorry. It's late. It's 12:17 a.m. if you want to know what time I'm recording this. These are congruent angles. And that was vertical angles. And two, did you find the other one? We actually have a choice. It's really up to you. It doesn't matter which ones you go with. I'm going to go with R and T. You could go with S and U. And if you recall, we know that angle R is congruent to angle T because those are alternate interior angles. And we should know that we need to use that, if you remember back, because of those little triangles. The little triangles mean that those lines are parallel. So from chapter 3, way back, we know that we get some alternate interior angles. It didn't matter which pair you use, that would work. Keep in mind that I can call them angles R and T because it's very clear which one is angle R. but it is not really clear which one is angle V, right? So we need to use 3 letters in here because it's not super clear. So now I have my 2 angles. This implies for me that triangle SVR is similar to triangle UVT by angle-angle similarity. And again, the angle-angle is all we have right now. And as we go forward in the chapter, we're going to get more and more of these, and that becomes the challenge. Is which one do you use, when do you use it, and which one is best for the situation that we are in. Okay, so that's page 1. I zoomed out so you can pause and zoom in if you need to see anything, but pretty straightforward stuff. A lot of the exact same conclusions. All right. So we're doing the same things here. Show the triangles are similar and write a similarity statement. This one's really easy, right? And this is a great example because these 2 triangles are just equilateral triangles and equiangular triangles as well. We know those are the same thing. So all of the angles here are the same, and they're actually all 60. And so all we have to do is we can conclude that angle G is congruent to angle Q. They want it in this order right here, right? That's the order they want it. So we're going to appease them. It doesn't matter what we choose G the same as, right? We can do G and R, G and S, doesn't matter. But in this case, we're going to go in their order, right? So angle G and angle Q are the same. Angle F and angle R are the same. That's good enough, right? We only need 2 pairs. We know that angle H and angle S are the same too, but it doesn't matter. So this is enough to imply that triangle FGH is similar to triangle RQS by angle-angle. Again, just need 2 pairs, because that means the third one matches as well. And it's actually true that all equal angular triangles are similar. There's always some scale factor, albeit it might be a nasty decimal, but they're all the same at some level. All right, some more interesting ones here. Show the triangles are similar and write a similarity statement. So we have triangle CDF. Again, if you have trouble tracking these, which some people do, that's the one on the left, right there. See the blue one? And triangle DEF, and that is the one in the green on the right. So we're trying to show those are similar. And so right now, first thing, we look at what's given to us, and we can actually find this angle right here. That one's 90. And we can find these 2 angles. That's not too hard, right? And it feels tempting to mark this to me. Maybe it's because it's midnight, but we don't know anything about sides yet. We just know angle, so we actually have to just do this work. So to find that angle, let's do the EDF. We would just do 180 minus 90 minus 58. That would equal measure of angle D. And so measure of angle D in this case is 90 minus 58. What is that, 32? So there's a 32 in that little spot right there, which means, of course, there's a 58 over here. So all you got to do is choose 2 angles to match, right? So we know that, first off, angle C is congruent to, and then here we need angle EDF. Again, notice angle C is very clear. Angle D isn't, right? So we need to make sure we name them properly. And 2, we got angle CDF. That's the 58 on the left side, if you're curious, is congruent to angle E, right? That's my 2 pairs of angles, so this implies, and again, they have our order for us right there. We want to match their order. So triangle CDF is similar to triangle DEF, and that is by angle similarity. Again, super boring because we only have 1 option right now. We will get more options eventually. So for now, just angle. And of course, you could have chosen to use the right angle. That would have been fine too. You just need 2 pairs, okay? Because again, for like the 5th time, if you have 2 pairs that match, of course, the third one matches too. All right, second to last one. A flagpole casts a shadow that is 50 feet long, right? And this might be worth drawing a picture here. But a flagpole casts a shadow that's 50 feet long. At the same time, a woman standing nearby who is 5 inches tall, 5 foot, it's late, 5 foot 4 inches tall, casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? And so it kind of depends on how you want to set this up, but we get 2 separate triangles, right? And the what you can get here is you can get little triangle. Thank goodness that this auto does it. I'm gonna copy and paste this. You can watch me do it if you want to. Nope, I want to copy. There we go. And paste. Okay, little triangle, big triangle. That's how similarity works, right? We got one small copy, one big copy. So I want to match. I want to match units. We have 50 feet for the shadow down here, right? That's 50 feet. One tick marks feet, yeah. And here I have 5'4" and 40 inches long. So we have a few options. We can do this in terms of inches or do this in terms of feet. Really, either one works just fine. I would just want to match them if I were you. So I think let's just go with inches. That seems like fun. I don't know which one's better here. Probably feet, but that's okay. So we don't know there's 12 inches in 1 foot, right? 12 inches equals 1 foot. So if it's 50 feet, we take 50 times 12, and that would give us our inches, yeah? 50 times 12 is 600. So we know this is 600 inches down here. Let's write inches in case you don't recognize the markings, right? 600 inches down here. And on the bottom one for the woman, let's put a little woman here. That's a high quality drawing, by the way. And here's our flag. Okay. This one down here is 40 inches, and we know that the woman is 5'4". So 5 feet is 5 times 12. That's 60. So 64 inches is the height here, right? 64 inches. So we, again, just to reiterate, this is 600 inches. This is already 40 inches, right? And 5'4" we decided was 64 inches. Okay? And we want to know how tall the flagpole is. So this feels pretty straightforward, right? Because we can just do 64 over x is equal to 40 over 600. And we're pretty comfortable with proportions at this point. But we should talk about the logic first, right? And the logic is, how do I know I'm allowed to set up this thing right here? And when am I allowed to do this? Now, you're allowed to do this if these triangles are similar, but we have not actually stated that yet, or we don't know that they're similar. And so what we need to do, and I don't actually love this argument, but if you're standing outside, and the book always claims this argument, and we're just going to buy it, just so you know, but it says that the sun hits everything at the same angle. And I'm not sure that's exactly true. I don't know the physics behind it. But they're saying that this angle right here and this angle right here, which is the angle that the sun hits you and creates that shadow, right? Because if you look down at this flagpole, right, that's how the shadow is created, is that right there. They're saying that that angle is the same. And I'm okay with that. Let's buy that, right? But on top of that angle, we also have the right angle right here that is created from the thing standing and the ground. And that is enough for angle-angle similarity. So the two, the two yellow markings are enough to imply, I want to imply, not arrow. That's enough to imply angle-angle similarity. So we can use the proportion on the right. Just a little bit of logic about why we can do this, right? Because this is an application problem of doing it. And then solving it's very simple, right? Cross multiply, you get 40 times x, that's 40x. And then 64 times 600, probably a big number, 38,400. Divide by 40. My calculator says 960. Now that's not a very genuine answer, right? How tall is the flagpole to the nearest foot, right? We need to answer the question they actually ask us. So it says 960, so 960 divided by 12 would give us that in feet, right? So 960 divided by 12 is just 80. So the answer here is the flagpole is 80 feet tall. So it doesn't matter if you use inches or feet here, you'll get the same answer. Just make sure that you have the exact same measurements. If you're not careful, I mean, you might get lucky if you do inches and feet, but just make sure you're being really, really careful, okay? And now here it says, a child who is 58 inches tall is standing next to the woman in question 6. So now, our woman from question 6, I'm just going to copy this little triangle over here. This was the woman's triangle with the flagpole, right? And now we have a slightly smaller child. Slightly smaller child is bigger in this picture that I just drew. That's cool. I like when I can draw. Slightly smaller. How's that? Similar triangles, just pretend. Okay? Use your imagination. This is a 58-inch tall child. And this is going to be an x down here. We don't know how tall. Again, the exact same argument works, right? We know that this is a right angle and that the sun's hitting this kid the same way. And so we actually end up with similar triangles again. And we can do 58 over 64 is equal to x over 40. Again, I went left over right and left over right. As long as we're consistent, we're going to end up with the exact same setup that we've been doing the whole chapter. Just be careful, okay? Then we just cross multiply like normal. 58 times 40. Glad I have my calculator out this time. 2320. 64 times x is 64x divided over. My calculator says 36 and a quarter inches, right? And I'm pretty happy. It just says how long, right? So we know that the child's shadow is 36.25 inches. But that was in inches, and we knew it was in inches. And if you put feet, you'd be wrong, right? That'd be a lie. So just make sure that you're very careful with what these are in. We know that in number 7, we matched all of our units. Okay? So big takeaway from this section is that we have angle-angle similarity that allows us to look at two triangles, determine if they are similar, and then use what knowledge we have to solve problems about similar triangles. We're going to, in the future, to look forward, we're going to add side, 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 and side angle side similarity in 8.3. And there's a few problems about that. And then in 8.4, a couple of theorems about proportionality. But that's it. Nothing too crazy after that. And so that'll be the end of our chapter when we get that far. But for now, I would like you to open the homework on Schoology and practice your 8.2 stuff. And so again, either do that on paper or print it if you have one, or wait till tomorrow and come grab it from me. But taking these notes is a great start. I hope you enjoy the rest of your e-learning day and have a nice day.